This conference
The
will
last
now be
topic is
recorded.
the combinational circuit. You know what is meant by combinational circuit? Now we are entering into the sequential circuit. Sequential circuit or synchronous sequential logic circuits also. But anyhow, this is called a sequential circuit. This particular unit is called sequential circuit. The name itself, the explanation is there sequential circuits. Sequential in the sense it obeys some sequence or it is in ordered. So the operation of this particular logical circuits is in some sequential, some sequence. So only we called this as a sequential circuits. The last chapter which we have discussed so far is called combinational circuit. Combinational circuit, you know the definition for a combinational circuit in simple or in one word we can define a combinational circuit is like this. That is, it produces the output based on the present state, or output is directly proportional to the present state. That's all. I repeat once again, combinational circuit definition is output is directly proportional to the input. It means that whatever be the changes, whatever be the change in input, that is directly reflected in the output. But the topic which we are going to discussing now is called sequential circuit. Is called sequential circuit. The definition for this in a single word, the output is not only depends on the input, and also it has some restrictions or some important terminology is called the output is depends on present state and the previous state, it means that what, that is a part of the output is taken and it has to be referred for certain process, then only we can produce as the continuous or sequence outputs in the output terminal. So only we called this as a sequential circuit. We will see each and everything in detail in the forthcoming sessions. No problem. This particular chapter deals about what? It is very important unit because application specific chapter or application specific unit, and also in your competitive examinations maximum 2 questions from this particular topic itself. One mark and 2 mark questions or 4 mark question may be possible in gate, gale, sail, bell, and some other competitive examinations. So this particular topic deals about the definition for a sequential circuit, then the comparison between the sequential circuit with the combinational circuit, and then latches. Another one important thing what we are going to discussing in this chapter means latches, also called as flip-flops. Flip-flops, that is digital switches with memory capacity or memory features. So flip-flops we are going to discussing, and its classifications. Flip-flops classifications, that is SR flip-flop, JK, P flip-flop, D flip-flop, and then JKMS, master slave flip-flops. So these are all the important topics in this particular unit, since it is very important for understanding all other or remaining part of this unit. So if you are strong, or if you are having a understanding about the concept of a flip-flop, that's sufficient to understand the entire unit. So whatever may be the questions, say for example back part of this sequential circuit unit is design of counters, and its classifications, say for example triple counters, ring counters, like that. So this is the applications of a sequential circuit. Sequential circuit application is what? It can be used as a counters and registers in memories. Maybe a one 2 mark questions in your end semester examination. So this part I'm talking about, this part. So this this first part is the fundamental, second part is the application. These two parts is linked with these portions. That means how to design that deals about this particular things. That means what is meant by state and its explanation, and then what is meant by state minimization, then what is meant by state assignment or state diagram, and then implementation of a circuit by using these two steps, that is state minimization technique as well as state assignment. Sometimes in some authors having state table. So based upon that we are going to implement in the sense practically we are going to design a circuit, that is called implementation, that is called implementation. Okay, so that's all about the chapter introduction. So what we are going to discussing, first one is the definition for sequential circuit and the comparison with the earlier chapter, that is combinational circuit. Then digital switch is called as a latch and also flip flop and its types. And then this particular flip flops applications to a certain circuits is called counters and registers, shift registers, especially that is in memory area, that is in memory areas. How we can design it or how we can implement it or how we can realize the operation of a shift registers and counters. For that some basics you should know, that is some steps. We have to draw the logical diagram or a truth table like in a combination circuit, here also there. So truth table, state assignment, state table, and then logical circuit implementation. That's all. Now I am entering into the subject now. So what is the sequential circuit? I'm going to define now. This particular point is very, very important. That is, what is the necessity of this particular thing? Sequential circuits needs what? Needs what? So the output has to be generated based on the present input. I think it has discussed in the earlier unit. The output has to be generated based on the present input. Now we are going to add one more terminology along with this present input, that is something is called past, input also, or the earlier performance, or in some author in some books earlier response. How we can take that earlier response? By taking the feedback from the output. So you please recall this block diagram from the earlier chapter. So this is input, that is in your combinational circuit. This is the input, this particular part is the output. This is the input side, this is your output side. So in the previous case there is no feedback like this we have discussed in the earlier chapter. So this is called combinational circuit. Now we are going to discussing about the circuit is called sequential circuit. Now we are going to discussing the circuit is called what? Sequential circuit. So it's what? It includes this particular part. This includes this particular part. In the earlier case there is no feedback, but now it is included. That means a part of the output is taken for analysis to produces the output. So it is not a new one. The same thing already we have discussed in the earlier chapter. But in the earlier chapter, there is no feedback. That means the output is purely depends on only the present input. But the past output or the response is also to be included in a sequential circuit. That's all. Okay. So sometimes we may call this as a one feedback network, or we can refer this operation within your control system fundamental feedback network. Okay. Yes. What are the types of sequential circuits? One is called a synchronous sequential circuit. Another one is asynchronous sequential circuit. Very important 2 mark questions in your end semester examinations. So I think 2 or 3 times the same question is in a Anna University in semester examination. So the synchronous means what? Simultaneously synchronous. Asynchronous means not simultaneously. So one after the another. That's all. So it is a sequential circuit. The operation is in sequence. That means the first operation is 0 means then 1, 2, 3, 4 like this. It follows certain sequences. In between these two, the difference is 1. Sometimes the same thing may be like this 0, then 4, then 8, and then 12. Like this, maybe another one sequence you may consider. So whatever may be the output, it is or it follows a certain sequence. It follows certain sequence. So we called this as a sequential circuits. But out of which again another classification is synchronous. Synchronous means simultaneously. Synchronous means what? Simultaneously, parallelly, or in at a same time, or in at a same time. Say for example, you might have take a counter or a simple analogy. You assume as like this. So any classroom is having 3 openings or 3 ways or 3 paths to enter the classroom. Suppose this is the classroom, you assume this is the classroom, you assume. So simultaneously all the path is opened for entering to the classroom. This is called a synchronous operation or parallel operation. At the same time, all the inputs or all the gateway allow the inputs. So this is a simple analogy for understanding the synchronous sequential circuit. So this is the analogy, but in our actual subject, what we have to convert this analogy into the subject means that is called clock pulse. That is called clock pulse. Each and every state or each and every stages or each and every units of the circuits, sequential circuit, each and every parts of the sequential circuits getting its clock pulse simultaneously or at the same time or parallelly, we called such a thing is called synchronous sequential circuit. Okay, it is very important fundamental, you should keep it in your mind. This is the fundamental. This is the fundamental. Though the question may be in your university examination, that is a 2 mark question. Types of sequential circuit, you can simply write it as a synchronous sequential circuit, asynchronous sequential circuit. Example for the both cases the same. Counters, shift registers. Only you have to add the terminology synchronous sequential counter or ripple counter, asynchronous ripple counter, asynchronous sequential counter, like that. That's all. So the example for this sequential circuit is counters, registers. I already told in the earlier slide itself, but now the classification. So the first thing is over. Synchronous means simultaneously, parallelly at the same time. Second one is asynchronous. It means that what? One by one. It means that what? One by one. Say for example, in some industrial applications, there may be a possibilities of, or there may be a requirements of counting certain sequences like this. It is the analogy. You please listen carefully. So this is the clock input. We will see everything in the forthcoming chapters, forthcoming classes. But anyhow, you please listen. So this is the actual circuit. So here I am going to give the clock pulse. Similarly, remaining 2 parts are 2 flip-flops also. This is called a flip-flop. This is called a flip-flop. This block is called a flip-flop. Each and every flip-flop is operates based upon the clock input. This is called clock input. So if I am applying a clock input to this flip-flop, it will respond. Similarly, the remaining parts also. Okay. So the first part is synchronous. It means that all the flip-flops in a counter or all the flip-flops in a sequential circuit gets a clock pulse at a time or simultaneously. That's all. This is called synchronous sequential circuit. But asynchronous means what? The first flip-flop only initially getting the clock pulse. Please listen carefully, understand carefully, because it's a very important fundamental to you to keep it in your mind for understanding all the counters in the back part of this unit. Okay. So I'm going to apply only one pulse to the first flip-flop, So what will happen? Second, third flip-flops will get the clock input from the output of the previous flip-flop. So I think you can get clear idea about synchronous and asynchronous. Synchronous means all the flip-flops in a circuit, even if it is a counter or a register or whatever may be the digital circuits, all the flip-flops gets their input simultaneously at the same time parallelly. So we called that as a synchronous. But the second part is asynchronous. It means that what? The first flip-flop only gets the clock pulse initially. The second flip-flop is gets the gate input from its output of the previous flip-flop. Similarly, third flip-flop gets the clock input from the second flip-flop's output. If suppose a fourth flip-flop is also there, means the fourth flip-flop will get the clock pulse from the third flip-flop output. So sequentially, not in a simultaneous or not in the same time, the clock pulse are applied to the circuit is called asynchronous circuit. That's all. If you're understanding this, that's all about this unit. That's all about this particular unit. So see the block diagram representation of a sequential circuit, which is similar to the combinational circuit. Provided if you forget this part, provided if you forget this particular part. So if you forget this particular part, till this is a combinational circuit. You familiar? So it has a input and outputs, input and output. But now the circuit is having feedback along with the memory elements, So this is that memory element. So what is the purpose of this? So in your future, if suppose you are entering into any industries, particularly on the automation industries, there it is possible. This memory unit, that application in industry is called data acquisition. That is called data acquisition. I think you might have studied the same thing or the same concept in your linear integrated circuit is called phase locked loop. So this is another one important topic in your LIC subject. There it is one of the important part. But here, again, you please listen carefully. But here, this memory element is called latch. I'm called this as a latch, a nice name, latch. You know what is meant by latch? So each and every person can enjoy this operation in your day-to-day life, latch. So many analogies are there for latch. We will discuss in later sessions. And also this is called as a flip-flops. And also we called this as a flip-flop. Okay. So everything is called or comes under the category of it is known as a digital switch. This is called as digital switch. So this is known as digital switch. So what is meant by digital switch? Very simple. It operates based upon the logics of zeros and ones. I'm talking only the fundamentals to you. It operates based upon the logics zeros and ones. Okay. Then now I am coming to this particular part, memory. Why these memory elements here? So I already said to you, the sequential circuit is not only depends on the present input, not only depends on the present input, and also the earlier response or the past response. So it has to be taken and stored in somewhere else for a minute or a certain time durations, and it make use it for the analysis in a sequential circuit operation. So this is called, this temporary stored area is called a memory element actually here, but that particular process is called data acquisition. That particular process is called data acquisition process. Then the question may be like this: how long time data will be stored here or available here? It depends on the input of this memory element or in exactly output of this particular point. Output of this particular point, it means that what, if my output is changing here, automatically the earlier data stored in this memory element is erased and the new data will be entering into this place. I repeat once again, what is the doubt or a question may be in your mind? How long duration this memory element store the data, and it has to be given to the input of a this particular part in a sequential circuit. Okay, that is the question. The answer is till the next input is reaching to this area. Till the next input is to be reaching, the data will be alive. Once the second data reaching here, first data will be erased. Similarly, the third data will appear here, second data will be erased. That's all. So it is called temporarily, a temporarily stored area is called latching. That particular process in digital electronics is called latching process, is called latching process. So it is called flip flops. So this is the application. If you understand what is meant by latch, what is meant by flip flops, that's the digital computers. That is the applications and operations of a digital computers. Since all the digital computers are a recent digital technologies is purely based upon this particular concept. So latch or flip flop is a unit. Latch or a flip flops is a unit. It is used to store the element that is only one bit. It is used to store the element. How many bits? Next question is another important thing. How many bits it can be stored? Only one bit. So single bit storing unit or storage unit is a flip flop. Is a flip flop. Okay, we will see the classifications and its operations in the forthcoming sessions. But anyhow, so from this block diagram representation, what is your understanding? So it has one memory element for making the analysis of a earlier response in the combinational circuit. So this particular process is called sequential circuit. This particular process is called sequential circuit. So it produces the output sequentially, depends on both inputs as well as earlier response. But in the previous unit, not like this. Previous unit, not like this. That's all. Now, based upon the discussions so far, we are entering into the important question in your exam point of view. That means in semester examination. If you are going to write the examinations for 3 hours, conventional examination may be one of the important question in your in semester examination. That is combinational and sequential circuit comparison. So nothing new. I'm going to giving the informations about whatever the things so far discussed, same thing only. So in combinational circuit, you know, the output is depends on only the present state, only the present state. But in the sequential circuit, not only the present state and also the past state. So that is present and past states, that is output. Okay, then what is the second important point? This combinational circuits based on the output obtained It is faster than the sequential circuit. It has the fast output or a response than the sequential circuit. Then there is no need of memory. There is no need of memory in a combinational circuit, but it has a memory unit, or it needs a memory unit because this particular purpose. So it takes the previous response as a past output, and it has to be given as a input to the sequential circuit. Okay, then according to the design and analysis part, it is very simple to design or easy to design and analysis. It is not like that, it has some complexity. Why? We have to see the logics, only the inputs, only the input logic. But in this particular case, what are the things you have to keep it in your mind? Not only the inputs, along with the input you have to consider the output logics. Output logics, that is the sequences of earlier output should be taken into the consideration along with the present state or a current input, that's all. Very important question in your exam point of view. So hope that you can get a clear idea about what is meant by combinational circuit and sequential circuit. Okay, then one more thing, if suppose the same question maybe in your examination, means you should write all these points. Along with this, don't forget to draw this particular block diagram. For a combinational circuits, you have to draw like this, and then you please mark it like this. That means there is no need of feedback. So in this part, that means a sequential circuit, so far the same, but in the output you have to mention at least like this, so otherwise you might have lose 1 mark out of 2 marks. Though you people are not uh, uh, properly giving the answer for this particular question, if you draw like this, if you draw this block diagram, that means for the combinational circuit and sequential circuits, so you will definitely get 1 mark. For the remaining parts, another one marks. So you please don't forget to draw the block diagrams, not only for this question, wherever there is a possibility to represent the things with the diagram, you please give it. Otherwise you may lose 1 or 2 marks. Okay, yes, now I am moving to the classifications of a logic circuits. Again it may be a 2 mark question, in your examination. So these are all the major classification. One is a combinational circuits, another one is a sequential circuits. Then again sequential circuit is classified into two. One is synchronous and another one is asynchronous, according to the clock input. Sometimes the question may be like this: how we can classify the digital circuits based upon the clock input? You have to write only synchronous and asynchronous sequential circuits are a circuits, that's all. Then according to the concepts we adopted, that is during the design process, one is Moore circuit, another one is Mealy circuits. So in your competitive examination, any one question may be possible from this particular topic, either Moore circuits or Mealy circuits based design. Then again fundamental mode operation, pulse mode operation in asynchronous sequential circuit, that's all. Again it is for your exam point of view, that's all. Now please listen again, more important fundamental I already explained, but anyhow. So here, 1 bit storage element, you know what is meant by 1 bit storage element? That is called flip flop or a latch. So latch or flip flop, both are same. What is its representation? This is the representation of a latch or flip flop in all the digital subject. So this is called flip flop or a latch, flip flop or latch, whatever may be. So input output. Then along with this, this is called clock. clock input. So this particular side is called input, this is output. So always it has two important thing. One is input, another one is clock input in the input side. In the output side, there are possible combinations of present state and the next state. Please listen, I'm talking a new terminology here. Present state and the next state. So in some authors this is called Q, and next state is or another state is Q bar. Okay, in some other authors this is mentioned as Q, this is mentioned as Qn plus 1, Qn plus 1. So this is Qn and Qn plus 1, both are same, both are same. Okay, you don't worry, you can understand such a things as in forthcoming sessions. But now here we are going to discussing about 1-bit storage element is called latch. Maybe one important one more question in our competitive examination. Its other name is called flip flop. Its other name is called flip flop. So what is available inside this latch or a flip flop? Inside the latch or a flip flop, what are the things is there? So it may be this one, or it may be this one, or it may be this one. That's all. Inside the flip flop, maybe this one or this one or this one. That's all. Okay. Now, if suppose you consider this, if suppose you consider this, what is this? It is a AND logic. What is this? It is also AND logic. Am I correct? Anyone? Am I correct? This is AND logic, and the next one is also AND logic. Both are correct. Anyone? Praveen Sri, am I correct? Is it AND logic? See here and tell me something. Is it AND logic? Is it AND logic? Again, is it AND logic? Pradeep, Ravichandran. Yes, Dilip Kumar says that it's a not logic. Very good. What about others? Someshwar. No, sir, Jayakumar. Okay. Yes, we will continue now. So I need at least one or two response from your side, sir. Otherwise, it's not a meaningful class. Okay. So all are a not logic. So the first diagram is directly NOT gate. The second one is logical multiplication gate along with the inverter. So it is NAND logic. It is NOR logic. It is a NOR logic. So it is a NOT logic gate is used in a latch or a flip flop. Here NAND logics. This is NAND gate. Okay, and then this is NOR logics. What is the definition for NOT? Output is opposite to the input or inverted from the applied input. What is the NAND logic gates according to the truth table? If any one of the input is 0, output will be 1. If any one of the input is 0, output will be 1. Is called NAND logic gate. And then NOR logic gates. NOR logic gate. NOR logic gate according to the truth table definition is if any one of the input is 1, output will be 0. Output will be 0, or all the inputs are 0, output will be 1. Okay, that's all. So now, according to this definition, now I am entering into the operation for this logics. First, you assume a equal to 0 and then b equal to 1. A equal to 0 and b equal to 1. So what will be the result here? My a bar is equal to automatically 1 here. Similarly, here also opposite to the previous one. Here, same assumption. My a equal to 0. What about b equal to 1? So here 1 and then here 0. Similarly, my a equal to 1 here, here 0, here 0 means here 1. Okay. So it is very simple. But what is the understanding from this? What is the understanding from this? This part is input. This part is a input. This is, that is, q and q bar is my output. Here only the important thing you should listen. So all the cases, either in the first case or in the second case or in the third case, what is my q? It's opposite only in my q bar. Q here 1, here 0. Here q is 0, q and q bar is equal to 1. That's all. So whatever may be the assumption, the same thing in all the three cases. This is the very fundamental thing in your sequential circuits. That is in latch or a flip-flop or a flip-flop. Yes. Now I'm entering into the first latch or a flip-flop is called SR. What is meant by SR? S means set, R means reset. S means set, R means reset. So sometimes in your end semester examination, the question may be like this: set, reset, flip flop, or set, reset, latch. Set and reset, latch. It can be designed either by using a, this is a NOR logic, this is a NOR gate, either in an OR gate or NAND gate or a NAND gate. Okay, you know about these two logic gates. These two logic gates is also called as universal gate, also called as a universal gate. So what is meant by universal gate means it is a derived gate. By using this we can get all the fundamental gates operation along with derived gates operations also, or in symbol. Universal gates are a gates by using the by using this we can implement all other logic gates operations. Say for example, if I am going to take the NAND gate, means by using this I can take or I can design a NOT gate, or logical multiplication gate is called AND gate, logical addition gate is called a OR gate, and also other gates, even same NAND operation or XOR operation or whatever may be the operation you want, everything can be get by using this, by using this. I think and the question may be asked in your first assessment test. Okay, that's all. So here set, reset, latch or a flip flops is designed by using a NOR gate, is designed by using a NOR gate. Okay, so it has two inputs, it has two inputs. One is R input, another one is S input. Why we called this as R? Since it is a reset and set terminals. Okay, S and R means set and reset. Then Q and Q bar, Q and Q bar or Qn. So Qn is the present state, means Qn plus 1 is the next state. So it is Qn, this is Qn plus 1 or Q bar or Q bar, whatever may be the thing, Q bar or Qn plus 1. So Qn is the present state, Qn plus 1 is the next state. Okay, then according to the earlier slide, what we understand that both are opposite to each other. That means complement between each other. That is a point given to you. The Qn and Qn bar or Qn and Qn plus 1 always complemented between the both. Okay. So what is the definition for this latch? Suppose a 2 mark question means you should draw this and then you please write it as R and S as a input. So this is the input, R and S as a input, and this is the output. Output is Q and Q bar or Qn and Qn bar or Qn and Qn plus 1. It has two inputs, out of which R and S as a input, Qn and Qn plus 1 is a present and next state. What is its nature? Its nature is always opposite to each other. If you are strong in this concept or a fundamental, that's all. Because now I am entering into the first latch operation. Latch operation, that is SR latch. SR latch. By using NAND gate here, this is the symbolical representation of SR latch, SR flip flop, also called this as a SR flip flop. So I already mentioned in the earlier slide, R is set, sorry, S is set, R is reset. Okay. Then what is this? So this is the inverter gate. This is the inverter gate designed by using a NAND gate. So not. So this is the latch. This is the latch. It stores only one bit or one bit data at a time. Only one bit data at a time. Afterwards, it will erase the data. When once the next data or the second data will be reaching to here. Okay. Now you please see the operation. Now you please see the operation. So here I'm not mentioning this particular terminal. So without this only now I am going to explain. With this we will see in later sessions. Okay. So listen carefully, very fundamental. Sometimes in your examination, a question may be possible. You should explain clearly. Yes. Now initially your S input is 0, R input is also 0. Based on which one? Based on the two input logic. That is, the first input is S, second input is R. So the input may be a combination of zeros and ones, 0 0 0 1 and then 1 0 1 1. Okay. Now I'm taking this. What is the output? Q and Q bar or Qn and Qn bar. That means here. Okay. So my set input is 0, reset input is also 0. Please listen. Both are 0. Since it is a NAND based NOT gate, output will be 1. Okay. Here also 1. What is the definition for the NAND gate based on the truth table? Any one of the input is 0, output equal to 1. But here it is acted as a inverter. So I am giving 0 here. Automatically output will be 1. You please listen carefully. One of the input of this NAND gate is 1. Here also 1. So my operation is purely depends on the input of the or other input of the each devices. Please listen. The first switch is here. One of the input is 1. For the second switch is also one of the input is 1. But we don't know what is the second input of both the cases. Please listen. Please listen. Initially, I assume that it is 0, Q equal to 0. So automatically, according to this definition, my Q bar is equal to 1. My Q bar is equal to 1. So please listen. Since it is 0, where it comes? Here, because it is connected like this. So it comes to here, 0. Okay. Then once it is 0 means, as per the NAND logic gates truth table, any one of the input equal to 0 means my output will be 1. I repeat once again. I assume that my Q output equal to 0. Hence Q bar equal to 1. That's all. That is the first assumption. Since I assume my Q output equal to 0, that Q reaches to here because the connection is like that. So here one of the input of this second logic gate is equal to 0 means output will be 1. So it satisfies this condition. Okay, it satisfies this condition. Whatever the assumptions we made, that is okay in this case. Then you listen still more carefully. This one will reach us to here, this one will comes to here. Okay, now you see the input of this NAND logic, input of this NAND logic, all the inputs are 1. So according to the NAND logic gate truth table, automatically output will be 0. So I would like to stress one important thing to you. All of you, you please strong with the truth table definitions for all the logic gates: AND gate, NAND gate, OR gate, NOR gate at least. Okay, then only you can understand the concept of this unit. Very simple, but you should have the fundamental about the truth table of each logic gate. So since I assumed this as a 0 that comes to here, that makes output of this logic gate as 1, that 1 reaches to here. Since both the input of this logic gate is equal to 1, my output equal to 0. Okay, now if suppose the second assumption is instead of 0 here, it may be 1, here it may be 1, it may be 1 instead of 0, it may be 1. Automatically my q bar equal to 0, automatically my q bar equal to 0. You please listen carefully. This assumption is over. My second assumption is initially my q output is equal to 1 in the previous operation, hence q bar equal to 0. So what will happen? Since it has to be connected here, since it has to be connected here, this 0 will comes to here, this 0 will comes to here. Listen carefully, this 0 comes to here. Therefore now this input equal to 0. Now this input equal to 0 now, along with this, along with this. So one of the input of this NAND gate equal to 0, my output equal to what? 1. My output equal to what? 1. That means what assumptions we made, same thing we will get. Okay, so this one is again connected to here, this one again will connect it to here. So now you see the inputs of the second logic gates, all the inputs are 1. According to the truth table of NAND logic gates, all the inputs are 1 means output will be 0, output will be 0. So here, so what is the understanding about this? What is the understanding about this? So whatever the assumptions I made, same thing only in the output. So please listen, I called this as a no changing state, no changing state. So whatever the thing I assumed, the same thing only here. So whenever my set and reset inputs are 0, here what assumptions I made, two assumptions I made here. So initially q equal to 0 and q bar equal to 1 and q bar equal to 1. So what is the new output we obtained? So q new nu vechikalang sir, and then q n plus 1 new. So here this is called no change, this is called no change, even if it is 0 1 and 1 0. Okay, so the first thing is over. Second truth table part. Now I'm going to take this particular input as 0, s equal to 0. Please listen carefully. Then r equal to 1, r equal to 1. Now my s is equal to 0. So all are in box now. Okay, for clear understanding. S input equal to 0, r input equal to 1. Since it is 0, the output of this one is what? 1. This one is what? 1. Since this is 1, it is 0. It is 0. Please listen carefully, very important fundamental I am explaining. With this, I am going to wind up the session today. We will discuss remaining part in the next class. Okay. So since it is 0, the output will be 1. Why? Because it's a not logic gates. Since the input equal to 1 here, the output here is 0. Okay. Output here is 0. And then one of the input of this gate is equal to 0, automatically my output equal to 1. Automatically my output equal to 1. Okay. I think it may give confusion to you. So I am going to erase all the things. Now I am explaining the same logic. 0, 1 once again. So my S input equal to 0, R input equal to 1. Since it is inverter, here 1, here 0. Okay. Again, please listen. Under this situation, I am going to explain one more thing. Initially, I made the assumption my Q is equal to 0, hence Q bar equal to 1. This is the assumption only. This is the assumption only. Okay. This is assumption. I am not taking the exact value. Since it is 0, my output equal to 1. Okay. My output equal to 1. This one comes to here. So all the inputs of this NAND gate are equal to 1. Hence output equal to 0. Okay. Then this is the first assumption. Second assumption, for the same input combination, initially instead of 0, I made the assumption this is a 1 and this is a 0. Okay. What will happen? Since it is 0, this 0 comes to here. This 0 comes to here. Please listen carefully. 0 comes to here. Okay. And then one of the input of logic gate is equal to 0 means my output equal to 1. My output equal to 1. Okay. That 1 comes to here. That 1 comes to here. Or once it reaches this 1, automatically it has to be changes as a 0. This answer I don't 0. Okay. That's all. It is the second logic I made. So initially I take 0, 1. So the output equal to what? And then 1, 0. Instead of that, I'm taking the second thing is 1. This 1 comes to here. This 0 goes to here. So one of the output from the earlier case is equal to 0. That makes this. Now you please listen carefully. It is very important thing because I'm going to change something now. So it's 0 changes to 1 and then this one goes to here. So that makes this as a 0. So that make this as a 0. So what is the understanding for this? What is the understanding for this? It means that I'm going to reset the value. I'm going to reset the value. Whatever may be the thing. So initially I made the assumption is 0, 1. Next case I make the assumption is equal to 1, 0. All two conditions my output equal to 0 and 1. That means I'm going to set my Q output equal to 0. I'm going to set or reset my Q output is equal to 0. Okay. So I'm resetting the value here. So I think you are having confusion now. No problem. You wait some more minutes for the next combination. You can get some idea exactly what is I am explaining. So my R input is now 1. Sorry, S input is now 1. R input is 0. It is a third case I am explaining. S is equal to 1. R equal to 0. Therefore, since it is a inverter, here it is 0. Here 1. Okay. Please listen. Under this situation, there are two conditions. Initial condition, my Q equal to 0 and Q bar equal to 1. Second case, I'm going to explain this 1 and 0. So you first listen this. So my S is equal to 1, R equal to 0, Q equal to 0 and Q bar equal to 1. This is assumption. Therefore, since it is a 1, here 0. Since this is the 0, here 1. Then once it reaches the 0, it is connected directly to this. So automatically what will happen? One of the input equal to 0 means my output is changing to 1. Please listen here only the change. Once it is 1 means since it is Q, here Q bar automatically it has to be changed to 0. So what assumption I made initially that has to be changed here 0 1. Now it is changing into 1 0. Okay. So I'm setting the value as 1. I'm setting the value as 1 here. I'm setting the value as 1. So whatever may be the value in initial case, that means initially 0 and 1. Now it has to be changed to 1 0. The next question. Instead of this, I'm going to take this assumption now for the since it is 1 and 0. Now the previous state equal to 1. Previous state equal to 1. Then once it reaches the 0, automatically it is 1. That 1 comes to here. 1 and 1, both inputs are 1 here. Output will be 0. So what will be the result or understanding? So in this particular combinations, S equal to 1 or equal to 0, it is going to set my Q output as a 1. In previous case, it is going to set my or reset the values as 0. Say for example, here if it is 1 means it is resetted to 0. But in this case, if it is 0 means it is setting into 1. Therefore, in our truth table of SR flip-flop is like this. This is a S input, R input, Q and Q bar. Q and Q bar. If it is 0 0 means what? 0 1 means what? 1 0 means what? 1 1 means what? Okay. 0 0 means no change. 0 1 means reset or set in some of this. So 1 means 1 0 means set. Now we are entering into this. Now the assumption is 1 1. Both inputs are 1 means here 0 0. Okay, please listen. It is another one thing. You should keep it in your mind. Both inputs are 1 1. That means this particular part I am taking 1 1. S input equal to 1, R input equal to 1. Since it is an inverter, here 0 and 0. Then one of the input of both the gates, AND gate is equal to 0 means 1 and 1. So it is not possible. Please listen. Both are 1 1 is not possible. So it is called indeterminate or forbidden or unacceptable level. In different authors mentioned in different way. So it is indifferent or indefinite value. So this is the truth table for SR flip-flop. I'm explaining only the SR flip-flop, not a CSR. What is meant by CSR? Clocked SR flip-flop. That means by using this. We will see such a part in the next session. So what is the important understanding from this logic diagram and truth table in SR flip-flop is latch is a unit which stores the data temporarily or temporary storage device. Okay, it stores only 1 bit data. It stores a 1 bit data. That means Q. So either 0 or 1. It stores either 0 or 1. For that, we are going to testing the different inputs, testing the different input values. What is the output? So if my S input and R input, SR is equal to 0 0 means whatever may be the states in earlier case. In earlier case, whatever may be the state or previous state, same thing. So we called that as a no change. It's opposite. If suppose both inputs are 1 1 means what will be the things? Indeterminate values, we cannot define it, or indefinite values, okay, or forbidden level. But in the middle case, it is very important thing. If my input is 0 1 means set equal to 0, Reset is equal to 1 means it is going to set as output equal to what? 0, or it reset whatever may be the things. Reset in the sense it makes that as a 0 0. Here 0 in all the combinations. Then the third part, if my input equal to 1 0 means it set the value as 1. My q equal to 1, automatically q bar equal to 0. So different authors mentioned in different way, but anyhow you should keep it in your mind. This is the fundamental. Okay, with this I'm stopping the today's discussion. So what understanding in this particular session, what is meant by sequential circuit and the comparison between combinational and the sequential circuit? The answer is combinational circuit is depends on only present state. Sequential circuit is in addition to the present state, previous state is also considering. Then classification of a logical circuits: synchronous sequential circuits, asynchronous sequential circuits, and overall classification of a digital logic circuits also we have discussed so far. And then flip flop or a latch means what? It is a 1-bit storage device, temporary storage device. How long time it holds the data? Till the next data will be reaching. Till the next data will be reaching. Once the next data is entering, automatically the previous data will be erased. Okay, so temporary storage device. Then the basic operations of a SR flip-flop we have discussed so far. Okay, with this I'm minding up the today's discussion, or this part of the discussion is over. Next